Welcome to this course of GCP with Terraform, and in this video we are going to learn how to provision a quick GCP resource with Terraform. So for that, let me show you first of all that I'm going to deploy a GKE Nodepool, that is Google Kubernetes Engine Nodepool configuration. And for that, what I have done here in the Terraform configuration, I have defined some of the GKE Nodepool configuration details. That's to start with, like first of all, I have created a Google service account. I have also provided in terms of the parameters like account ID, the account ID in GCP that is used to generate the service account email address, and a stable unique ID. And whenever you are working with GCP, make sure that it is unique within the project, and it should be 6 to 30 characters long, and it should match the regular expressions like A to Z to comply with RFC 1035. We should also need to have a display name whenever we are creating a GCP service account. It can be updated without creating a new resource. While we are provisioning the resource like Google Container Cluster, so as of this recording, HashiCorp Google provider that is works with 3.85.0, we need to provide the name of the cluster, that's a primary cluster of the GKE, and the location in which this cluster master will be created, as well as the default node location. So suppose if you specify the zone like US Central 1A, the cluster will be like a zonal cluster with a single cluster master. If you specify like a region such as like US West 1, the cluster will be like a regional cluster. Similarly, like you need to also provide along with the name and location of the cluster, like remove default node pool. So if it is true, it just goes ahead and deletes the default node pool upon cluster creation. If you're using like Google Container node pool resources with no default node pool, this should be set to true alongside setting like initial node count that could be at least of 1. You can also set up like initial node count, so the number of nodes that's to create in the cluster's default node pool. In regional or multi-zonal clusters, that could be like a number of nodes per zone. It could be set if the node pool is not set. If you're using like Google Container node pool objects with no default node pool, you will need to set this value to at least of 1. Then you need to also provision the resource called Google Container Nodepool, that is with preemptible nodes. Here also you need to provide here the parameters like the name of the node pool cluster name, as well as the cluster details, like on top of, which clusters on top of which this cluster node pool to be created. You need to provide the initial GKE cluster details ID. You can also provide the node config details. So here like you can provide some of the features like whether it's going to be a preemptible node or not, whether the nodes are created as a preemptible VM instances or not, the machine types, the name of the Google Compute Engine type, the service account details, that the Google Cloud Platform service account to be used with the node VMs, and the OAuth scopes as well. Then on this outputs.tf file, you can specify that the output with the GKE container cluster ID details along with the corresponding cluster ID value. In the providers.tf, make sure that you provide the credentials, that your Google Cloud service account credentials file, your project details, as well as the region details. Now in the variables.tf file, make sure that you provide your GCP IAM service account credentials, your project name, your region details, your zone details, along with the service account ID, the service display name, the primary cluster name, the primary cluster location, the node pool cluster details, node machine types. So such kind of details you need to provision too. And once it is done, then you can obviously set first of all like the backend. If you're using like the initializing the backend like local backend, so you can basically use the Terraform init command, then followed by the Terraform plan command. So Terraform plan, as we all know, that works with something like Terraform plan followed by the out, that is, you can save like the tf plan output file, and along with that, once the plan has been successful, then you can go ahead and you can provision this Terraform apply for this provisioning of the corresponding GKE resource. And also like whenever you are applying, you were just going to execute the Terraform apply, you can use this corresponding tf plan file as well. So this is how we have provisioned here this corresponding GKE cluster node pool with the help of Terraform. And let me show you here how does it looks like once it has been provisioned. So this is now I am in my Kubernetes cluster, and if you see here this corresponding this GKE cluster, how does it look like? So if we go here inside this particular cluster, so we can see that the cluster name, the location type, it's a regional type of cluster. It's a corresponding region that has been set to US Central 1. It is also being for high availability and resiliency perspective. This cluster is also being provisioned on top of using like 3 availability zones itself. So it's using like node pools use the default node zones until unless like a location being specified. It's also using like the regular channel or the release channel as part of the GKE cluster configuration. Total 3 nodes that has been provisioned. We can also change this cluster size so that we can add a new node pool, we can delete or edit an existing node pools as well. On the automation perspective, the maintenance window can be set to any time, and also like no notification has been enabled as of now. No vertical pod auto scaling has been enabled, but yes, we can enable it as part of our Terraform configurations as well. Auto scaling profile is also being in the balanced mode. If you also see that this particular GKE cluster is not as a private cluster, network side it using like a default VPC and a subnet, and also like cluster pod address ranges it's using that corresponding IP addresses as well. Only like HTTP load balancing that has been enabled for this cluster. On security standpoint, like the shielded GKE nodes that are being enabled as well, and rest of the other services like Google Groups for RBAC or legacy authorization that could be enabled as part of a requirement. If you see for other features, we can also enable Cloud Run for Anthos as part of a requirement if it is needed. Cloud logging is enabled for system and workloads logs. Cloud monitoring that is also being enabled as part of the system level. Also that if you see here, the compute engine persistent disk, that CSI driver, that's being also being enabled, and Anthos service mesh is disabled, but we can add it as part of our deployment perspective. On the node side, if you see that this is actually this cluster defines that the corresponding CPU requested, the CPU allocable, memory requested, memory allocatable, storage requested, and storage allocatable details for the nodes. And in the node pool specific details, there are 3 nodes in a particular node pool with the E2 medium types of the machine type, and it using basically a container optimized OS with container D. If you come over the storage tab, so you could be able to see that as of now there are 3 types of storage classes has been used, like standard read write optimized for GKE, as well as premium read write optimized, that's for PD SSD type. And on the logging perspective, we could be also able to see that both the cluster logs as well as the autoscaler logs as part of our resource deployment as well. So in this quick demo, we have observed that how we can deploy GKE node pools, GKE cluster, Google Kubernetes Engine node pools cluster with help of Terraform. So I hope this video has been informative for you, and I look forward to see you in next videos. Thanks for your time.